everything turned to shit. So that's just the motivation I needed to go ahead and start welding this thing and slide this chassis forward. Well, good afternoon. Buggy and things in here are right where I left it. That was last Sunday, and it is Saturday afternoon now. So get this axle up off the ground, move some things around, do a little welding, get that rear end sort of solidified a little more, do some better welds on that, and go back to doing some shock testing and figuring out, what length shocks I need for this thing. So here we go. Okay, well, it's been a lot today. I don't know how much of this was caught on the time lapse, the GoPro. The battery kept running out, kept getting interruptions. It's been a lot, but this is a 14-inch Mockup-Shock. And what I figured out with the 14-inch versus the 16-inch, vertical travel wise and packaging, with the 14-inch mounted in this configuration, it's got to be mounted there. I'm pretty much going to have to ditch the leading arm idea, simply because the distance between the shock and the frame rail here it's just too close. And with these big old 3.0 shocks and a 5 1/4 inch spring, it just will not clear that frame rail at full droop. Anyway, okay, back to the numbers. 14-inch coilover mounted in this position. This is the happiest it is. I have 15 1/8 inch of overall vertical travel.
The next morning.
All right, y'all, this is where we're at. So yesterday, and I'm not sure if the time lapse or the GoPro caught a lot of what I was doing. It was a hectic day, but what I did yesterday was I took my mock-up 16-inch shock and cycled the suspension, figured out where the shock is best suited to be placed on the axle to utilize the shock and the packaging of it. Again, trying to make sure that the upper shock mount stays below the hood line. And I figured out that I can utilize a 16-inch shock, no problem, by mounting the lower mount of the shock either right over top of the axle or just behind this outer portion of the axle, about at the same level as the link. The 14-inch shock, of course, will work as well, but I don't get as much vertical travel out of the 14-inch shock. Yeah, go figure. So what I figured out was, after doing the math and measuring everything, the overall vertical travel I was able to get out of a 14-inch shock is 15 1/8 inch overall vertical travel. The 16-inch shock I was able to get 18 1/4 inch overall vertical travel. So with all of that being said, the thing now is to figure out, is that all usable travel? And when I say, is that all usable travel, what I mean is, are the drive shaft angles going to be happy at full droop? Are the drive shaft angles going to be happy at full bump? And right now, at full droop, I'm going to go ahead and say not so much. It droops out too much for the drive shaft angle to be happy. And if you watched some of the earlier videos, I was pretty impressed that I was able to get this pinion to stay flat throughout the whole suspension cycle. And while that would be a great thing, I think if I didn't have as much travel, it's not necessarily a great thing here. What I need the pinion to do at droop, as it droops out and gets lower and lower and lower, I need the pinion to climb and point at what would be the carrier bearing that connects to the mid shaft right over in through here. So what I've done is I experimented with making this upper link longer, and it's doing kinda what I want it to do, but it's not quite climbing as much as I want it to. And the problem is making this upper link longer just by rotating out the heim. What it's doing is it's pointing the pinion upward more, and it's running into the link at full bump. So now what I want to do is experiment with making the upper link longer overall by changing the position on the upper chassis mount. So if I move that upper chassis mount back more, my theory is, hopefully, that what it will do is keep the pinion flat. If I set it flat at ride height, it'll keep it somewhat flat all the way up to bump. But as it goes down below ride height and droops out, the pinion will climb. So now we're going to test that theory by taking and cutting these tack welds on this tube here on the uppers and moving it back. Hopefully that's going to work, and hopefully that will answer some of these questions. This thing has so much suspension travel, and I want to be able to utilize it all, but you know, getting a 16-inch shock is great if I can utilize it all. If not, then you might as well just get a 14 and be done with it, because you've got big expensive shocks that are 16-inch, but you have them limited with a limit strap. So that's what I'm going to do now. That's what this whole phase is about. Testing and figuring. It's a lot. There's not a whole lot of talking to be done. There's not a whole lot of discussion to be said about it, other than that's what I'm doing. And it would be kind of boring for me to sit here and discuss suspension geometry and theory. I do know the upper link needs to be longer than the lower link to get the conditions I want, which are pinion to climb at droop, I think. So just rotating the link on the heims to make the actual link physically longer rotates and points the pinion in different directions, but it doesn't necessarily change the characteristics of the arcs everything swings on until you change the position of the link mounts at the chassis side. That's the beauty of having a tube chassis. You can do that. On a factory frame vehicle like a Toyota truck or an older Jeep, you're pretty limited. So anyway, that's what we're going to do, and hopefully my theory pans out. All right, here we go. All right, so I moved these upper link mounts back, and this was the simplest way to gain another inch of length. If I need to move them back more, if I'm gaining in the right direction when I cycle the suspension out, what I'm going to have to do is do a counter notch on this tube and slide it in here and, you know, brace it up some more. But until I know that this is giving me the results that I want as far as pinion climb at full droop and staying level at bump, I'm not going to do anything more here. Right now, that's about as far back as I can take it. I probably could relieve this a little bit more right here just to get it past this weld, but that's about as far as I can take it for now. So anyway, here we go. Well, it's been a day. I learned that making this upper length longer yielded me a couple of degree change, actually about 1 degree change in the pinion angle. So when the when the suspension droops out, pinion points upward. As it cycles up and gets past ride height and goes up into the bump, it starts to rotate downward a little bit, which is what I wanted. Everything's pretty tight, especially with the amount of travel that I have. I'm gonna need to figure out how to mount a 3-inch shock in here. I'm gonna plan on tying it into the lower link mount, just make it all one big solid unit. And then, since I moved these tubes back, they were up here to make that upper link longer. I'm gonna have to move these over and maybe rotate them upward a little bit because I'm dangerously close to the frame rail there. So lots of learning, lots of figuring, lots of standing back and looking at it. trying to figure out what makes the link suspension work with what seems to be the wild card, which is the high pinion. That high pinion presents all kinds of challenges, but I think we got it figured. Yeah, not a whole lot of info, not a whole lot of talking in this video, hopefully. A lot of time lapse, a lot of me going back and forth and shortening and lengthening and moving and doing all kinds of stuff to these upper links. Just a lot. So anyway, thanks for watching. Please like, subscribe, share, and we'll see you on the next one.